Okay, hello my dear friends. So in this video we will do this question, minimum number of days to make m bouquets. So it is a very classic, again a very classic example of binary search and a very good question, and it is a medium level question. So let's see what is written here. You are given an integer array bloomDay. So you are given an array bloomDay, an integer m and an integer k. So you are given two integers m and k. Okay, so you want to make m bouquets. Okay, we have to make m bouquet, and to make a bouquet you need to use k adjacent flowers. So you need to use k adjacent flowers means if k is 2, so and you need to make 3 bouquet. So in each bouquet you need to use 2 adjacent flower because k was 2. So you need to suppose there are 6 flower in the garden, so and k is 2. So first 2 you will make one bouquet, and second 2, from second 2 you will make second bouquet, and from last 2 you can make third bouquet. Okay, like this. Return the minimum. Okay, the garden consists n flowers, and ith flower will bloom in the bloom of ith day. Okay, bloom day of I, and then can be used in exactly one bouquet. Okay, and return the minimum number of days you need to wait to be able to make m bouquets from the garden. If it is impossible to make m bouquet, then return -1. So okay, I hope the question is pretty simple. Let me explain it to you again. Suppose, see, bloomDay here, this is the bloomDay array. Okay, so this is the bloomDay array, and it is 1 10 3 10 2, and m is 3. So what does this m giving us? So this m is giving that you need to make 3 bouquets. Okay, so m tells us that we need to make 3 bouquets. And what does this k tell us? So it tells us that k is what? K is adjacent number. Okay, so we need to make 3 bouquet and 1 flower adjacent. So 1 adjacent means you need to only select 1 flower to make that bouquet. So let us see what happened in first 3 days. It is written here in explanation. X means flower bloomed, and dash means flower did not bloomed. So see, if day is 1, so in one day, see, first flower, this bloomDay of ith 0, bloomDay of 0th, it is taking only one day to bloom, so it will bloom in one day. So see, it is cross here, and other days are not taking one day, so we cannot bloom other flowers on same day. So means in one day we got only one flower. Suppose in second day we got 2 flowers because this is taking 2 and this has already been bloomed in one day. So okay, that's it. And in third day we got 3 flowers. See, the minimum number of days, maybe in fourth day we can get 4 flower, or in, suppose if we take 10, if day is 10, we can bloom all these flower. But it is asking us to give minimum number of days. See, it is written here, you need to return minimum number of days. So what we will do in this question, we will apply binary search plus logic of O of n. So let me tell you first how we will do it, and this example is good to tell you, I think. Yes. Okay. Yes. See, this was the array bloomDay, and m is 2. So what we need? We need to make 2 bouquets, and we need to select 3 k adjacent flowers. Okay, 3 adjacent flower each time. So and this array dot length is 7. So yes, we can make 3 bouquets. We will select 3 flowers and 3 flowers, and 1 will be left. We don't want to use that. Okay, so output is 12. Why? You would be saying that suppose if number of days is 1, can you bloom all these flowers in one day, or can you make any bouquet in one day? This is taking 7 days. This one is also taking 7 days. This one is also taking 7 days, and this one is also taking, and this is taking 12 days. And you cannot bloom any of the flower in one day. Can you bloom any of the flower in 2 days? Definitely not. Yes, because the minimum number of flowers, see, what will be the minimum number of days to bloom a single flower? I am asking about single flower. So the minimum day to bloom a single flower is 7, because first flower is taking 7 days. Okay, but coincidentally second flower is also taking 7 days, and these all flower are taking 7 days, and these two are also taking 7 days. So how many flowers we got? From this we got 4 flowers, and from this we got how many flowers? 2 flowers. So you would be saying that yes, we can make see, sum is 6, and we can make 3 flower bouquet each. But See, you did not read the problem statement correctly. Why? Because see, if we take 3 flower each from 6 flowers, we do not want to do this. We have to select 3 adjacent flower. Suppose from here, let me change the color. From here we can select these 3 7. Okay, I am extracting this 3 7 and I am making one bouquet. M is equals to 1 right now. We have made one bouquet. And now the situation is like, see, if I draw it here, okay, I am making an array. See, all these flowers are bloomed and this 12th is not bloomed. The flower which is taking 12 days is not bloomed yet, and other are also cross. See, I have made that example. Now see, suppose if I take these 3 flower, we can make one bouquet. But what I am seeing here, we cannot take these 3 because this is not bloomed yet. And suppose if it is not bloomed yet, we can also not take these 2 because these are 2. We need to make 3. We need to have 3 flowers to make one bouquet. So we cannot. So how will we approach this question? So what we saw in this question, we saw that the minimum number of days required to bloom a single flower is the minimum element of that array. The minimum element of that array was 7. So 7 was the minimum day to bloom a single flower. And what is the answer of this is 12. Why? Because on 12th day each flower is bloomed, and now it's up to you. You have to select any 3 flowers, any 6 flowers. So you can do that. So adjacent 3. So we can make, and maximum day is 12. So 7 to 12. So what we will do, suppose we check for 7, that is it blooming on 7th day, and then we check for 8, then we check for 9, and 7 8 9 10 11, and just like this, that 12. So we will go like this. And suppose we first check for 7, then check for 8, then check for 9, then check for 10, then 11, then 12. So it will take huge time, like O of n. We are traversing this array, then we are finding it in O of n. So that would be O of n square. The solution will take O of n square. We have to optimize this. So we will use binary search. We will keep our L here and R here, and then we will play with mid. Shall I show you another example? So let me show you this one. See, this is also a good example. And if I make this example big, yes, this is good. See, now you would be saying that minimum is 1 here and maximum is 10 here. Okay, so if we see, let me write another numbers between this: 2 3 4 5 6 7 8 9. Yes, and let me make these number big. Okay, oh, I think we cannot do that, but we can do something like this. See, now see it carefully. If I select one day, I can bloom only this flower, and any one of these will not be bloomed. So this is not a good solution. We need to make how many bouquets? We need to make 3 bouquets, selecting k adjacent one flower each for each bouquet. Okay, and we need to make 3 bouquets. So if I select 2, I can bloom this one as well as this one, but these 3 flower would not be bloomed. If I select 3, now I can bloom 3 flowers, and see, these 3 are not adjacent to each other, but we need to make one. We need to select one adjacent because k is 1. So we got 1 flower each, so we can make 3 bouquets. And suppose you would be saying that minimum is 1, the approach I told you, and maximum is 10. Suppose I select maximum 10, so on 10th day all of these flowers would be bloomed. Yes, but we have to select the minimum number of days. Minimum is 3, maximum can be 4 5 6 7 8 9 10, and 100 days also maximum, but we need to select the minimum days. So now I am solving this problem. So for that we'll make a function int add adjacent count. This will count the adjacent days, and vector, it will have a vector like this. Okay, and I'm copying this parameter exactly. And see, I'm making this bloomDay to ARR. I hate any other array name. So I'm making this bloomDay to ARR, and we are also passing a days, int days. Yes, int days. Oh wait, yes, int days, and yes, this is a function. What this function will do, int count. I am first declaring my variables, int result, and for int I is equals to 0, I less than what, I less than arr dot size, yes, and wait, I plus plus. Yes, so what this function will do, suppose we select day number 1, so it will check on day 1, is this bloomed? Yes, it is bloomed. So it will make my result 1, because we need to select one adjacent. So my result is 1. Is this bloomed? Not, and not. So we will got 1 from this. So okay, how this function will work, if see the code, you will understand it very easy. So if it is if days, if days count is greater than what, or greater than equal to, yes, greater than equal to arr of I. Suppose if day is 10, okay, and arr of I is 7, so it would have been definitely bloomed. Yes, okay. If day is 7 and arr of I is also 7, yes, it have been bloomed that day as well. Okay, so arr of I, then it means the flower, flower, has bloomed. Okay, flower has bloomed if days are greater than. So what we will do, we will do count plus plus, but remember this, in this example, suppose here our count in for first time, suppose our number is 7, so for first time, for first 7 our count will increase 1, then for this 7 our count will increase to 2, then for this 7 our count will increase to 3. Okay, then when this 7 come, our count should not increase for 4, it will again set to 1, because we had to select only 3 adjacent, and we got 3 adjacent here only. So we'll increase count if count, count, is greater than what, k, or greater than equal to, it will not greater than, it will, if count is equals to k, then what does it mean, we have to set count to 0 again, and before setting count to 0 we'll have to result is equals to result plus plus, we have to increment the result, then decrease the count to 0 as. Okay, now else what need to do, else I need to do I need to do else? Yes, suppose now we got a count of 1, at this 7 our count reset to 0. Okay, our count resets to 0, resets to 1, but when this 12 come, the count should set to 0, because now the streak is break. Okay, streak has been breaked. So now count is equals to 0. Yes, perfect. So this is our function, and this will return us result, return result. Perfect. Now what I will do, I will just use binary search, int left. Shall I use left or L only? L is good. Star min element of what, arr, wait, arr dot begin, begin, comma, arr of end. Yes, and I'm copying this to R. One condition which I did not tell you is max element this. See, this will give us an iterator, and we are using this star. This star is a pointer. This will convert that iterator to integer value. Okay. Now we will apply binary search while. Do you want to know which condition I did not tell you? See, L less than R. This binary search is very easy. Like, we have applied it so many times that we know what will happen. And if you write on paper what is this binary search doing, you will definitely understand it very good. So int mid is equals to, oh sorry, int mid is equals to L plus R minus L by 2. Yes. If so what we will do, we will pass this function some things. So what we will pass in this function, if this function, and see, these days are what? These days are mid. We are selecting a mid and that is our day. So arr comma m comma k, m comma k, and then what we will do, we will pass this mid as number of days, and then what, suppose this is greater than, we passed a mid, suppose we pass our mid is 13, our mid is 13 and these days are these, so these all would be bloomed in 13 day, so these all would be bloomed. So this is a good answer. So I'll decrease my r towards 13. Okay, or is less than, first take the example of less than what, less than m, and then we will increase L is equals to mid plus 1. Okay, less than okay, else if it is greater than or equal to, we will do what, r is equals to mid minus 1. If it is less than okay, if it is greater than equal to, we will decrease r to mid minus 1. Yes, otherwise this. And at last I would like to return this, return L. I think this is fine. R is mid minus 1. Wait, if I want to see this condition, suppose this give me my minimum number days are 13, suppose this gave me 15, so 15 is less than, no, so R will be at 14 place. Now this give me 12, 12 is less than, so L is okay. And what will happen when L and R are at same place? That is a equal to condition. Okay, that's fine. Okay, so if I submit this, any mistake I am making? Am I making any mistake? Okay, yeah, see, this was the test case, I did not tell you, that is the mistake. See, days are only 5 and you need to make 3 bouquet, and each 2 adjacent flower cannot make. Suppose this flower was 1, this k is 1, then there is a possibility we can make, because see, k is 2, you need to have 2 flowers each bouquet, and days are not sufficient for that. So if m into k is greater than what, arr dot size, then return minus 1. And see, make this long, because why, because this will, m in your test case constraint is, see, constraint m will go up to 10 raised to power 6, it will cross the range of integer. Long, perfect. I guess it is perfect now. Wait, any extra bracket? This bracket is closing here. Yeah, perfect. So I think this is perfectly fine. Let's see, will it give us the right solution? Yes. And if I submit this, this will be, I think, submitted successfully. Yes, accepted. And if you analyze its complexity, this is working in O of n time, nothing special, but this is functioning in O of log n. So we have reduced the complexity from O of n square to O of log n, and that is much better than n square, I guess. Yes, analyze complexity. See, O of n log n type. Yes, okay. So O of n log n. Okay, so I think I have done this question, and yes, thank you.